Hello, hope you're having a good day. To anyone who's an external student watching this, my name is Sophia and I am a select entry tutor based in Melbourne, Victoria. And today I'll be going over the solutions to Patterns Worksheet 1 that I've made for my personal internal students. However, if you're interested, I do have the link to the worksheet in the description box below. So with the change to the ACER exams in 2023 and for this year, 2024, particularly for quantitative reasoning, we can expect to see more pattern style questions, more unusual patterns that test students' reasoning skills. So we'll be going over a couple of key formats today, as well as some general tips. So we'll start with the general tips here. Tip number one is to avoid tedious work. So if you're flipping through your exam and you come across some sort of problem, and you may very well know how to do the problem, but it seems like something really tedious, as in you're going to have to add all of the numbers up in a certain range, or you might have to list a dozen or so numbers or add 10 numbers in a row. If it appears to be something a bit tedious, this should set off a bit of an alarm bell in your mind. And that's a point where you need to take a step back and actually consider, is there another way to still get to this particular answer? This is pretty applicable for all kinds of maths tests, including AMC, Maths Olympiad, and so on. Typically, you're not actually going to be asked to do tedious work, and especially not for the select entry exam, not even the ACER format. Because the way that the questions are set out is that students should typically be able to attempt them between half a minute to 2 minutes time per question, right? And so you're not going to be asked to do something really tedious. So if you know the solution, but the solution involves adding up 20 numbers in a row, that's when you need to take a step back and actually think, is there another way to do it? So I would say definitely don't go down the path of doing tedious work. If the tedious solution is the only one you can think of, maybe put it aside and come back to it when you have time, because usually that isn't going to be the most efficient solution. So I would set it aside until I can think of something slightly better to do. If I've done the whole exam and I'm desperate to get a few more correct, I may take some time to go ahead and add 10 or 20 numbers together, but usually I wouldn't go ahead and do that. So that's tip number one, avoid tedious work, okay? The examiners did not write the problem to test you on your arithmetic skills or get you to do a whole bunch of tedious work. Moving on to point number two. If you have identified, oh, this is a kind of question where there's some sort of pattern going on, but you don't know exactly what to do. You can't quite put your finger on it. It's not exactly the same as ones you've seen in class or past tests before. Here's what you should do. If you're in doubt, you should conduct a little experiment. What I mean by this is perhaps it's a pattern where you're adding on a changing amount each time. Or perhaps it's some sort of pattern where they want to know the answer for the large range or 20 numbers later on into the pattern. What I would encourage you to do if you're unsure is to conduct a little experiment. You don't have to list all the numbers up to the 20th one, because that breaks sort of rule number one, avoiding tedious work. But you could maybe list out the pattern for the next 2 or 3 answers in that pattern and see if you're able to spot anything. I'll show you how to do this in a few of the questions that I've laid out for my students here. So let's move on. Let's have a look at these questions over here. I did write them myself, so I'll be pointing out a few things as we go. Okay. So for questions 1, 2, and number 3 over here, these are all divisibility patterns. So if we look at question number 1, it says from 1084 to 1943, how many numbers are divisible by 7? Now, there's going to be some students who know, well, divisible by 7 just means it can go into 7, and they're going to start listing them, and that's going to take up a lot of time. Quite frankly, in these examples, where the ranges are so large, it would simply be impractical and impossible to do this efficiently during exam time. So I'll show you how I do these divisibility patterns, okay? So I think, well, I've got 1084 and I've got 1943, okay? They're asking, how many numbers are divisible by 7? Well, divisible by 7 also means multiple of 7, Okay, so that's something you want to be really comfortable with. Maybe in class, your teachers always said divisible by 7. You want to make sure that in your notes and from your personal understanding, you know that divisible by 7 also means multiple of 7. You want to be very flexible with that. So no matter how someone asks you, you don't kind of get thrown off by some slightly different wording. You're still confident, you still know how to do it. Okay? Let's think multiples of 7. Maybe I'm unsure, okay? Let's say we're going back to year 8 Sophia. I have no idea how to do this pattern. That's a true fact, by the way. When I was in year 7, year 8, I did not know how to do these patterns when prepping for the exam. Let's think anyways. What if someone asked me for a really small range? What if someone asked me, well, hey, Sophia, from 22 to 50, how many numbers are divisible by 7? And here I am going to do something manually. I'm going to list them out. So 7 times 3 is too small, but I know I've got 7 times 4, which is 28, 7 times 5, which is 35, 7 times 6 is 42, and 7 times 7 is 49. So I know here there's a total of 4 multiples of 7, okay, or 4 numbers that are divisible by 7 from the range 22 to 50. Yeah, interesting. There are also 4 numbers when we go from 4 to 7, inclusive of those n numbers there 4, 5, 6, 7. There are 4 numbers there. Interesting. So the same rule can then be applied even if we have these larger ranges. Okay. Some people might be quite intimidated because they go, well, this one's easy. It's 7 times 4 up to 7 times 7. We're working with really big numbers here. But the working out process should still be the same. And you actually don't need to worry about too much here because it says from 1084 to 1943. So basically, these numbers are consecutive, right? There's no gaps or anything like that between them. So you're just counting from 4 to 7, 4, 5, 6, 7. Or in the case of these larger numbers, probably much larger, right? But they're all numbers in a row. So you don't really need to worry that you're going to miss any or anything like that. Okay? So this is what I mean by do a little experiment, okay? If I really didn't know, especially during the next few months while you still have some time to practice, untimed, obviously, don't do this. Actually, you can. Mainly, I would say you guys should try to do this during your untimed exams at home. Like maybe you might not be able to get this question when you're doing it timed, but then when you have some extra time at the end, do it. And in your exams, if you're really desperate, do a quick little pattern here, but quick little pattern experiment. But we want to try to avoid it in the exam if we can, but it's not too bad. It's definitely better than still doing tedious work. Okay, so let's observe for 1084 to 1943, and we're going to take the same idea here. Okay, I'm going to erase this over here, so hopefully everyone has that note down. And now we encounter another problem. Some people might say, well, Sophia, 22 to 50 was really easy. I know all my 7 times tables, right? Whereas 1084 to 1943, they're really random numbers. Like, what do I do over here? And that's perfectly fine as well. That's pretty understandable. So what you guys are going to have to do is 2 bits of division, okay? You'll go 1084 divide by 7. 7 times 1 is 7, and subtract 38. 7 times 5 is 35. 34 over here, 7 times 4 is 28, leaving you a remainder of 6 over there, okay? Now, some students get a little bit stuck at this stage. So they go, well, Sophia, is 7 times 154 the multiple that we should be starting with, or do we need to round to the next one? So I want you guys, if that's something you're thinking at the moment, I want you guys to actually think, what does this actually represent, essentially, right? We're saying 1084 divided by 7, it can go in 154 times and then like another 6 individual units added on, okay? So 7 times 154 does not make 1084. It's off by 6. So if you did just 7 times 154, it would come out to be too small. So on the lower end of the range, we're actually going to have to round up when there is a remainder, okay? The smallest multiple that works here is 7 times 155, okay? We're then going to do the larger one, which is 1943 divided by 7. 7 2 is 14, 54, 7 times 7 is 49, 53, 7 times 7 is 49 again, leaving you a bunch of stuff at the end. Now, some people are then like, oh, okay, Sophia, I know what to do now. I'm going to round up to 278. So you actually don't do that for the upper range, okay? you actually need to just go with 277 because what we're basically saying here is, hey, 7 goes into 1943 277 times, and then like another 4 over here. Let me write that a bit better. Another 4, okay? Well, we're not going to do anything with that extra 4. So 7 times 277 is still within that range, okay? And if you're someone, I totally understand if in the exam you feel really intimidated and scared and you're like, I can't remember, do I round up or down? I know we said something about this, but I don't know if it's up or down. Just do a quick little experiment. Just do 7 times 277, see if it fits in the range, and then add on 8 to it, see if that still fits into the range or not, and you'll be able to figure out for yourself. Okay? Now we have these. Now remember before we had 7 times 4, 7 times 5, 7 times 6, 7 times 7, okay? And then what we did was we figured out, well, there's 4 over here. That was easy though, because we could list it, all right? Now I'm going to show you guys where the other error that I've typically seen in class pops up. The other key error and issue that people have over here is that they don't actually know how to do this subtraction properly to get the full proper answer. Okay, so I actually want to include the multiple of 7 times 155 and the multiple of 7 times 277. I want to include those n numbers there. So what you need to do when you're subtracting is you need to do 277 minus 155 plus 1, okay? This is really important. You need to do the plus 1 to show that you're including the number at the end, okay? So very often in my classes, in past years as well, I've asked people to do this problem and they're able to do this step flawlessly. And then I look at all the answers that people are sending through and submitting to me, and they're always off by 1. I'll get an answer that says 100. I'll get like 5 answers that say 100 and another 5 answers that say 101 because people actually don't know to add that extra 1 there when we want to include the n numbers. Okay, so we need to be really super mindful of that. Then you just do your subtraction over here, 2, 2, and 1, 122, and you add 1, and you get 123. And that's, yeah, the whole answer over there. That's the number of numbers that are divisible by 7, or multiples of 7, between 1084 and 1943. It's 123 numbers. And that seems like a very reasonable number as well. It doesn't seem too crazy, so I'm fine with that, okay? If you get something that's quite obviously off, for example, between 1084 to 1943, there's only like about 900 numbers. If you get an answer that says there's 500 multiples of 7, which would total to 3,500, that's very obviously wrong, and I would redo it at that stage, okay? So that should be your answer. Now, because I've already shown you guys that in a bit more depth, I'm going to do questions 2 and 3 a little bit more quickly, okay? So hopefully you guys can bear with the working out over here. It might get a little bit crowded, okay? So we've got 1937 to 3459. We want them to be divisible by 9. So start with the lower bound. 1937 divided by 9, 9, 2, 18, 13, and over here, 47. 9 times 5 is 45, leaving a remainder of 2. Remember, when it's on the lower end, we round up. So we'll go 216. Upper bound now, 3459 divided by 9 as well. 9 times 3 is 27, leaving you with 7 and 5. 9 times 8 is 72, 39. 9 times 6 is, that's not right. Sorry, not 9 times 6. 9 times 4, I meant. Apologies. 36, and you get a remainder of 3. Remember this one, we don't really care about the remainder. We're just going to round down. 384 is fine. Okay? Then figure out the number of numbers from 384 to 216. So you're going to do 384 minus 216 like this. 8, 6, 1. 168. But don't forget, you have to plus 1 at the end to include the numbers themselves. So add 1 and you get 169. So that's the answer for number 2. Okay, and then I'm going to do number 3 over here as well for everybody. Okay, so what we're going to do over here is it's 1293 to 4092 and multiples of 5. So you start off with 1293 divided by 5. 5 2 is 10, 29, 5 times 5 is 25, 43, 5 times 8, blah, blah, blah. So we're going to have to round up in this case, 259, okay? You see, I actually don't care about the remainders that much. I am being a bit lazy here. So to be honest, if this was a school test and someone said, oh, we're going to be checking all of your working out, I would be writing my remainders a little bit more tidily over here. But if in this exam you're really wanting to just zoom by very quickly, you don't have to do that. As long as you know you got to round up after 258, that's fine. It doesn't need to look that beautiful. No one's going to be looking over your working out aside from yourself. So you don't need to spend too much time making it super pretty. It just needs to look acceptable. This one's 480 something something. So you go up to 480. 480 minus 259. Get a 1 here, get a 2, 2, 2, 1. Don't forget, plus 1 here, 2, 2, 2. So those are the answers for the first three, okay? The first one, let me write that down as well. So 1, 2, 3, 169, and 2, 2, 2, okay? So there's that over there. Now, it's looking a bit crowded on this page, so I might just erase the previous working out in just a moment, but you guys can all see this over here on the screen. So I might just erase everything so it's a bit tidier to work with, okay? Let's move on to this variation of the first problem, which touches on even and odd numbers, okay? So we're all good with the first three. We feel confident. We feel good with them. And we then might see something like this on the exam. They might ask, from 124 to 1099, how many numbers are even and how many numbers are odd, okay? Or this other smaller range at the bottom. And some students might get really intimidated at this stage. So like, how am I supposed to know? So I actually want to point out a few examples and things to you guys, okay? I'm going to show you guys a few different ways to do this problem, and I'll show you the smartest one at the end, okay? So over here, imagine you just have the numbers 1 to 10, okay? I'm not even going to say 1 to 100 because sometimes that's too many for people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go in and count for yourself how many even numbers there are and how many odd numbers there are, okay? Even numbers, 2, 4, 6, 8, 10. Oh, there's 5 of them. And odd numbers, 1, 3, 5, 7, 9. There's 5 of them. But you guys already knew that, okay? What if I changed the end number? What if I made this, instead of 10, what if I made it 11? So I have 11 here. So in this case, I would still have 5 even numbers, but I would have 1 more odd, okay? And the reason for that is because we start on an odd number, 1, and we end on an odd number, 11, over here. And so you'll see in this case, you're going to have 1 more odd than you have even, okay? Likewise, if we had a different pattern, perhaps we were going from 2 to 12 instead. Just bear with me while I edit this over here. If we had 2 to 12, and I'm going to erase the 1, and I'm going to add on my 11 and 12 as well. Just a moment. Over here. Okay, pretend the 12 is green, okay? In this case, we would actually end up with 1, 2, 3, 4, 5. Oh, have I? No, so I thought I colored this funny. Let me actually make it green. Let me make it easier for everyone to see. 1 second, guys. Let me make this 12 green as well. There, I almost counted wrong myself there. That's why I wanted to change it. So there are 6 green, and that means 6 even, and 5 odd. Interesting. So this time, because we start on an even number and end on an even number as well, we end up with 1 more even than odd. Okay, cool. So hopefully you guys can sort of see how this pattern is turning out at the moment. It all depends on the numbers that we start and end with, okay? But one more point I'd just like to make over here is you're never going to end up with a situation where you have a lot of even and very few odd, and vice versa, okay? Because similar to what I said for the first set of divisibility patterns, these numbers are going in order, right? So the most that you can sort of gain, quote unquote gain, an extra even or odd number is just going to be always a difference of 1. So if you told me, oh, in this pattern, there are 600 even numbers and 500 odd, I would just not believe that because that seems very fishy to me. That doesn't seem quite right, okay? So that, yeah, you should only ever get your answers differing by 1. It shouldn't be more than that. So I would definitely look out if I've got 2 answers that are really different, okay? Depends on the case and the wording of the problem, but if it's just all consecutive like this in a row, you should only see a 1 difference between the even and the odd, okay? Now, I'm going to erase this now. The next thing I want to point out to you guys is your definitions, okay? And something that I see in my top students from year to year, every single year, is that they are very on top of it when it comes to the English and maths, okay? They're able to be very flexible and switch in between terms really fluidly and easily. Okay, so when you see the number or you see the word even, you don't want to just think even. And the top students, the students who are really good at Olympiad and AMC, they don't just look at that and go, oh, it's even. Even is even. When someone says even to them, they're immediately thinking, oh, that also means multiples of 2. That means multiples of 6. That means multiples of 8, multiples of 10, so on and so forth. That's what those students immediately think about, which gives them that extra edge, okay? But if we go back to our most basic definition of even simply means to be divisible by 2, okay? As in you can divide this number by 2 and get a nice whole number as a result, okay? So when they ask you, hey, how many numbers are even? All you're basically actually being asked is the same thing as question 1, except divisible by 2. So if you were able to do the first set of problems, you should be able to at least do this part when they ask you how many are even, because they're just asking you divisible by 2. That's all they're saying. So don't feel really intimidated if the wording is different. Sometimes you just need to take a step back and actually have a think about it. Oh, what does even really mean? What does odd really mean? What are they actually looking for here? Okay, so I'm just going to do that super quickly, the even numbers, and then I'm going to talk about 2 different ways that we can figure out the odd. Okay, so here we've got 6 and 2, and here 1099 divided by 2, 5, 4, and 8. Oh, not 8, 9. Sorry, guys, my arithmetic is not that good. Okay. One more smaller point to point out over here. It does say from here to here, so we assume that those n numbers are included just based on that English wording there. So this one, because it divides in perfectly, 124 with 2, I'm just going to use 62 as my lower bound. But do be quite careful if they use the wording in between or if they say exclusive of those n numbers. If they say between, technically, 124 is not between 124 to 1099. So in that case, you'd actually have to round up to the next nearest one, which would be 126, which is 2 times 63 instead. Okay. So you just want to be really careful with any variation in the way that they're phrasing that question. Okay. Just another red flag for everyone to be quite wary about. Okay. So we got 62 to 549, and I'm just going to do the same thing that I did before, 549 minus 62 and plus 1. So I'll just do that on the side here. All right, so I get 487 plus 1, which is 488. Great. There are 488 even numbers. Now I'm going to show you 2 ways to figure out the number of odd numbers. The first way is not the smartest, but it's still a really handy trick to know. What does it mean when we say odd? Well, odd, you can define it as things divisible by 3, 5, 7, 9. Right, you could think about that. You could, but that's actually not perfect. That's not a perfect definition because for example, something that's divisible by 9 could be divisible by 2 as well. So it's not really a perfect definition. That one's so-so at the moment. Just think a little bit further. Well, I know that odd means it's not divisible by 2. I know that odd is the opposite of even, right? And that's where we can actually go in and do the problem. Well, everything that's odd isn't even. That's all we know, right? It's sort of like in a class, for example, if there are 20 students, for example, I tell you there's 5 girls and the rest are just the rest, it means there must be 15 boys because in the classroom they're either girls or boys. It's one of the two. So if you do the total number of students, 20 minus all the girls, you end up with all the boys, right? Or let's say in a room there are 40 children and adults, and I tell you there are 12 children. Well, the amount of adults must be the people who are not children. You're either a child or an adult, right? So that's interesting. So if only we were able to figure out the total number of numbers from 1099 to 124 and subtract all the even ones, we would be left with all the odd, okay? So that's the first way that you can do it. What you do is you figure out the numbers from 124 to 1099, which I will do over here for everybody, okay? 5, 7, 9, okay? So I get 975 plus 1. Don't forget, you want to include the n numbers there. I know 488 of them are even, so I just subtract those. And here I get 8. 2 plus 6 is 8 as well. And 8 minus 4 is 4. Oh, okay. That means there are 488 odd numbers as well. And we just do a quick common sense check with what I mentioned before. You should have roughly the same number of even and odd. Here it's exactly the same. So that's a pretty good sign. I'm pretty happy with that answer. Okay. But now I'm going to show you guys an even smarter way to figure out how many are odd. Okay. What you can do, and you may have noticed this before when we were doing the pattern from 1 to 10, 1 to 11, and 2 to 12, is that it all depends on those numbers that are at the start and end of the range. We knew that from 1 to 10, when you had an odd number starting and even number at the end, you got the same amount of even and odd. And when we had 1 to 11, you got one more odd than even. And when we had 2 to 12, we had one more even than odd. There's only 3 scenarios, right? So if we figure out and just have a look at the problem here, this starts off even and it ends up odd. So that's sort of like a 1 to 10 scenario. That means we're going to have the same number of even and odd numbers here. So actually, if I was really smart, so this is like your top student who's taking the exam, a superior student who's taking the exam, they've figured out how many are even by doing the whole divisible by 2 thing, and they don't actually even need to do this part for odd. They just know, oh, looking at the end numbers, it should balance out. So the rest are going to be exactly the same. How many odd is going to be the same as even. Your really top students will be able to do that without having to bother to do this. But the reason why I show you this is because it can still be handy. There are some other worded scenarios where you may potentially need to use this. So I just want to show everyone anyways. Okay. So if it helps, I'll list out the 3 scenarios for everybody, okay? Scenario 1 is where you start off on even and you end on odd, or vice versa. Who really cares what we start and end with? It can be the other way around. In this case, you're going to have the same number of even as odd, okay? If you start on odd and you end on odd, okay, you are going to have one more odd than even. Okay, and the final scenario is just the sort of the vice versa of that. Okay, number 3, even, starting on even like 2 and ending on even like 2 to 12, you're going to get one more even number than odd. Okay, so it just really boils down to 3 scenarios like that. Let's do the second question. I'm going to do this one relatively quickly because I've just shown everyone in detail how to do question number 1. Okay. So what we do here is we go, well, 3, 4, 6. We're going to divide this by 2. Okay, 1, 7, 3. Great. 9, 8, 3. We're going to divide this by 2, 4, 1, 9, 1. Okay, so 1, 7, 3 to 4, 9, 1. And actually, before I do that, I also want to show everyone if I'm just having a look through the problems. Oftentimes you want to have a look before you jump right into it. I know that's a little ironic considering I just jumped into question 2, but if you're just having a look through the questions first, just look with your eyes. 3, 4, 6. Oh, that's even. 9, 8, 3. Oh, that's odd. So that tells me that it's actually going to be the same scenario as question number 1, where I'll have the same number of even and odd numbers there. Okay. So just figure out how many numbers are here. 491 minus 173. 7 plus 1 is 8. To 1, 3, 318 plus 1. So you get 319. Looking at the end numbers there, I know the rest are going to be odd. Easy, 319. I don't even need to do anything for that second step. So I can do this question really quickly, really effectively. And when I'm doing it really quickly on my own, I can definitely get this done under the 30-second time sort of limit, okay? And this year, with the changes, the amounts of questions in quantitative and maths as well, you actually get a little bit more time. So you actually have even more than 30 seconds if you're someone who's a bit slow with their arithmetic. Let me just show you guys, just for the sake of this as well, what I'd do if it ended on an odd number instead, or even number. Let's say it was 984 instead, okay? I would get 320 for even, and then I would know, because it started on even and ended on even, I have one more even than odd. So when I'm looking at my odd numbers, I go one below that. I won't write 320 as well, okay? But going back to this one, let me just fix it, 319, okay? So I've just taken everyone through the divisibility patterns and a variation of this, which is the even odd question. Okay, we now have a few other scenarios. The first one touches on the nth term of a pattern, and the second one touches on 3 fun worded scenarios. So I'm going to erase the working out from before just to keep things tidy. Okay, and let's have a look here. So the nth term of a pattern, this is actually relatively easy to do, and it's going to save you a ton of time. So definitely make sure you know how to do this and write it down in your notes somewhere, okay? So it says, Sophia thinks of a pattern. These are the first four terms, 1, 5, 9, 13. They ask you, what is the 40th number and what is the 105th number? Okay. And straight away, when I look at this, if I was seeing this for the first time in year 8, I would be like, well, yikes, I'm not going to count up to 40 numbers. I don't have the luxury of time to do that. So I'm going to have to do a bit of an experiment, try to figure out what's going on. So if I really had no clue what to do, here's what I would do to try to figure it out at least a little bit. Well, 1, 5, 9, 13, luckily that pattern isn't too crazy. It's pretty obvious that they're all going up by 4. That's great. So I know the first 4 numbers of the pattern. Now, someone's asking me for 40. I can't give you 40 if I'm listing them. But how about I try to count up to the 7th pattern? Let's just try that, guys. Okay, 13 plus 4 is 17. 17 plus 4 is 21. 21 plus 4 is 25. Yes, okay. So interesting. So that's the 5th, 6th, and 7th number. Now look at this, okay? I've just done, and I'll do this in orange to make it abundantly clear to everyone, plus 4, plus 4, plus 4, okay? Because I've jumped up 3 places in this line from 4 to 7. 3 places, 3 sort of bunny hops there. And each step is a consistent size, as in each step that I'm jumping up by is 4 every single time. So from 13 to 25, I've jumped up 12 places because there are 3 steps, okay? And each step has got a size of 4. So 3 times 4 is 12. Add that onto 13, okay? And hopefully at this point, you guys can see the pattern of what's going on, okay? You just need to figure out, well, how many steps do I have to jump up by? What's the size of each step? Multiply and add that onto the number, okay? If anyone would like me to write out those steps, I can as well. I'll just do that quickly at the bottom if that helps anyone. Number 1, you want to figure out your step size, and you can just figure this out from the pattern. 1, 5, 9, whatever it may be, okay? And usually it's going to be consistent, so don't be too intimidated by this step. Number 2, figure out the amount of steps, okay, that you need to take. Before, we wanted to go from the 4th number to 7th number. 7 minus 4 is 3. So number 3 is you multiply the step size by the number of steps, and make sure you don't stop here. I have a lot of students in my class who often, they get to step number 3, they get really excited. They're like, yes, I know what I'm doing. I've gotten to the answer. That's it. And usually your examiners, who are very smart people, they will usually put that as one of the answers to try to trick people who are over eager with answering the question. So make sure you remember at step 3, you haven't actually figured out the final answer. What you figured out is how much they're jumping up by. Rather than doing, say, like 30 of these bunny hops up here, you've just figured out if I took one collective leap, how big that size would be, essentially, is what you've done there. So step number 4 is you need to go ahead and you need to add whatever you got from step number 3 onto the last known number, okay, which in this case would have been whatever the 4th number is, okay? If those steps don't make too much sense to you, that's all right. I'm going to do the next 2 or 3 problems and hopefully it'll become a bit clearer. Okay. So here, we know the first 4 terms. We know the step size is 4, and we want to go from the 4th number, which is 13, up to the 40th number. So do 40 minus 13, okay? And that's going to come out to be 27. So every single step size is 4, and I want to go up by 27 steps, right? So 4 times 27. 4 times 27 is 108, if I've done that correctly. So 108 is not the answer. 108 is how much one big collective step would be. Rather than taking 27 like really mini steps, 108 is what one massive step would be from the 4th to the 40th digit, okay? So you just make sure you add 108 back to 13 and you get 121. And that's your answer for the 40th number. I'll show everyone really quickly for the 105th number using the same pattern. So step size is 4, but this time I'm going from the 4th number to the 105th. So I'm going to go 105 minus 4 and I get 101. So I'm going to do 4 times 101 and I get 404. That's what one collective leap from the 4th to 105th number would be. Make sure you add on 404 to 13. You get 417, easy, okay? In my opinion, the nth term of a pattern is even easier than the first two examples that I've shown everybody today. So this, you can for sure get this done in maybe 20 seconds or so if you're really on top of things, okay? Maybe even less for students who are really quick with their arithmetic, okay? Now, here's another one over here. I'm going to show you guys a variation of this pattern, okay? Sophia thinks of another pattern. These are the 7th, 8th, and 9th terms respectively, 12, 17, 22. They actually ask you, what is the first number and what is the 200th number? So the thing that's a little bit new over here is actually asking you for the first number, which is working backwards because this is the 7th, this is the 8th, and this is the 9th. Interesting. However, the working out is just going to be the same, except the only thing you want to do is instead of adding at that final step, you want to subtract, okay? Because even though it's from the 7th number to the first, this is the kind of question that's going to set apart your very top student and your average student. So the average student, they're smart enough, they're already sitting the exam, they know how to count from the 7th number to the first, right? But still going to take you a bit of time. And to be honest, for me, unfortunately, I am someone who's not blessed with arithmetic skills. My own students know this. I will very often stuff up basic multiplication, basic division in class, algebra, factorize things wrong all the time. Not because I don't know how to do the problem. I know how to do the problem very well, but I'm just clumsy. I don't check. I rush. It's always been a problem. It still often is a problem for me, to be honest. I know it's a red flag for me that I need to look out for. And so I know that if I was to count from the 7th number and subtract 5, like 6 times to get to the first number, to be honest, I would probably mess it up if I'm having a bad day. I'm under the pressure of the exam. I myself would mess it up. And I'm sure many students would as well, even if they know how to do it. So we're not going to do that, okay? Your superior students are going to subtract it all in one big go, okay? So firstly, figure out the step size. Obviously over here, it's 5. Right now, I actually want to go from the 7th digit to the first digit, or 7th number from the first number, I should say. So the step size is 5, and I want to take 6 steps over there, okay? So you just do 5 times 6, which is equal to 30. That's 1 collectively backwards as well. So you are going to do 12 minus 30, please, everybody, okay? Do not do, some students accidentally do 12 plus 30. That's a red flag. And worse, some students sometimes do 22 minus 30. So when students do 22 minus 30, what that actually shows me is that they're not super clear about what numbers they're actually working with. Because right now I did 5 times 6. I did the 6 there because I'm wanting to go from the 7th number down to the first, okay? If you wanted to do 22 minus something, you could go 5 times 9 because you're going from the 9th number back down to the first. But why would you make your calculation bigger than it needs to be? It doesn't make sense. So don't do that, okay? When you're wanting to go backwards, start with the lowest number you know. Whereas if you want to go up, okay, to a bigger number, you want to start with the biggest number that you know, okay? 12 minus 30, negative 18, okay? 200th number, same thing. Now be careful though, right now we're on the 9th number, okay, and we're wanting to go to 200. So that is 101 numbers. Step size is 5, 101 times, let me write that out a bit more nicely. 101 times 5 is 505. You are going to go ahead and add that onto 22, so you get 527, and that's your answer for the second one. So this is the answer for the first one, negative 18. Answer for the second one, 527, okay? Hope that's clear for everyone. I'm just about to get into the last 3 worded scenarios over here, okay? Just to keep things clear, I'm going to erase the working out from before, okay? You can scroll back in the video if you want to note that down somewhere, okay? So today is a Saturday. What day of the week is it in 200 days? So these sort of patterns, you actually notice something quite similar with them. It's like there's a certain order to things, okay? Or like days of the week, okay? Could be the order that someone's putting beads onto a bracelet, could be the alphabet, right? Could be anything that has some sort of order to it. But they want you to be able to figure out, hey, what about in 200 turns? What is it? In 50 turns, what is it? Now, if you're really on top of things, you'll just see that this is just essentially a disguised version of the previous problem above it. They might fancy it up, they might add some sort of scenario, they might add a bit of a story to it, but when we really boil it down to its core, it's asking the same thing. So I'm going to show you guys how to do these ones as well. Days of the week is a pretty popular one over here. You guys know how the days of the week go: Monday, Tuesday, Wednesday, okay? So today is a Saturday. What day of the week is it in 200 days, okay? Now, I don't blame you if you look at this and you're like, oh, I don't know what day it is in 200 days. How would I know? Well, imagine today's Saturday. Imagine 7 days from now, it would be another Saturday. Another 7 days from now would be another Saturday as well. So you know, and this is something you subconsciously know as well, days of the week repeat every 7. They come in a set of 7, right? And you know, for example, if we start today on a Saturday and I tell you, oh, you know, there's 20 weeks that fly by, okay? In 20 weeks' time, who's like, if you're in year 8, you'll be done with the exam, which is great. But in 20 weeks' time, the exam and time will fly by. And if it's exactly 20 weeks, it'll be another Saturday. In 200 weeks, right? It'll be another Saturday. You know this, right? So you just really got to figure out how many weeks there are in 200 days, and you can adjust for the little bits at the end. I'll tell you how to deal with the remainders in a second, okay? So we do 200 divided by 7. Make sure you do this carefully over here. 7 times 8, 56, remainder 4. So you get 28 remainder 4. Let's put aside the remainder 4. We'll deal with that in a moment, but let's start off with that 28 over there. That 28 means there's 28 lots of 7 in 200. A lot of 7 also means a week, okay? And another day that we're going to end on another week where we're going to end on Saturday, okay? So there are 28 weeks in 200 days, okay? So we end up on a Saturday, right? We know Saturday goes to Saturday, okay? But often what a lot of people don't know what to do is, well, with the remainder 4 days. So before you do that, if you're feeling a bit overwhelmed, you're feeling a bit intimidated, and you're like, I don't know what to do with those 4 days, don't panic. Once again, do a little experiment. Just see in 10 days' time, okay? Today is a Sunday in real life. When I'm filming this video, it really is a Sunday. In 7 days' time, I know it's another Sunday, right? And then in 8 days' time, I know it's a Monday. In 9 days' time, it's a Tuesday. And in 10 days' time, it's a Wednesday. So if I ask someone, oh, what day is it in 10 days, right? I know +7 takes care of it. Like I can do Sunday to Sunday, that will take care of 7. And then another 3 on top of that after Sunday, not including Sunday itself, but counting again, Monday, Tuesday, Wednesday, it will take me to the 10th day. So same thing here. Just from Saturday, count 4 more days, okay? Sunday, Monday, Tuesday, and Wednesday. So in 200 days, it's going to be a Wednesday over there, okay? Basically, you just want to take your really big number here, divide it by the size of that pattern. So days of the week would happen to be 7, and then you're just going to adjust for the ending there if needed. Really important tip, if you guys got 28 exactly, right? Sometimes some students, like for days of the week, it's more obvious. But sometimes in other scenarios, students actually don't know, do I end on what I started with, like Saturday goes to Saturday, or do I go to the next number or the next new thing in the pattern? Do I go Sunday? Okay. Some people get stuck there, but just think days of the week. 7 days, today's Saturday, 7 days is Saturday again. So if you got perfect 28, right, say there's some other numbers, you got exactly 28, it would end on the same thing that you started with. Be really careful with that. Don't then go Sunday and then like count another bunch from there. Or don't just say Sunday is the answer. Just be really careful with that. Hopefully it's clear what I mean there. Okay. And now let's move on to question 2. So it says, Sophia rotates the perfume that she wears. On the first day, she wears a rose perfume. On the second day, she wears a jasmine perfume. On the third day, she wears a magnolia perfume. If she wore jasmine perfume today, what perfume does she wear in 143 days? So what you do over here is you list out the order. It's rose, jasmine, magnolia, but she starts with jasmine, so you might go jasmine, magnolia, rose. Same thing, doesn't really matter, okay? 143 divided by 3, 3 times 4 is 12, 23, 3 times 7 is 21, remainder 2. So you get 47 perfect sets of this pattern, and you have 2 left over, okay? So if you're feeling a bit stuck, just write jasmine, magnolia, rose. Today's day 1. Imagine just in 6 days, okay, including day 1, right? 1, 2, 3, jasmine, magnolia, rose. You would end up on rose. That would be the 6th one over there, okay? So you end up on the final number number in the pattern, hopefully that made what I was saying before clear. Sometimes some people think that it lands on Jasmine again and they get a bit confused. So it's a little different for the days of the week compared to these other patterns here. So just be really mindful of that, because that can sometimes cause some issues. And then another 2. So after Rose, another 2, Jasmine, Magnolia. So you end up with Magnolia as the final one. Okay. Moving on to number 3, Sophia's making a bracelet. She uses red, blue, green, and purple beads in that order. Needs 27 beads. Pattern size is 4. 27 divided by 4. 4 times 6 is 24, leaving you with a remainder of 3. So that's 6 perfect sets of this pattern. Remember, when you do one perfect set, you end up on the last one, which is going to be purple over here. Okay. And then you add on another 3. So rose, oh, sorry, not rose, red, blue, green. So you end up with a green bead at the end over there. Okay, so that is a review for these patterns. I do predict that these are going to be quite relevant for ACER this year, especially with the changes in quantitative reasoning and just the change to ACER maths as well. I do hope that this video was informative for you. If you do have any questions, feel free to leave them in the comments. I'm also going to leave my email in the description box below as well, so you can contact me if you've got any questions as well. I do offer tutoring and exams, so feel free to message me about those. But I hope this was really helpful to everyone. Enjoy the rest of your day. Thank you.